Hey guys, Pankaj here. Welcome back to my YouTube channel. So today we are going to start the first topic of statistics. So we will be starting with mean, median, and mode. Okay, so we'll see what is mean, what is median, what is mode, and what are the fundamental problem with mean, and how to overcome with this. Okay, so we'll see all the mathematical calculation and their formula, and we'll do a couple of visualization also so that you can easily understand all the formula as well as all their concepts. Okay, so let me share my desktop. Okay, so I'm going to import all the library, whatever is required library. So we'll see NumPy as NumPy and Pandas as PD, Seaborn as SNS for plotting the data. And we'll use matplotlib PLT because we may have to do some modification in the graphical properties. Okay, and let's see. Yeah, and we have one more library called statistics. So those who are using Anaconda, statistics will be there pre-installed. If you are not having and you're not using Anaconda, go ahead with command prompt and do pip install statistics. Okay, under this we are having ready-made formula for mean, median, mode. However, even if you don't use, we can get it done using NumPy and pandas. Okay, so remember in NumPy we can get mean and median, but mode is not there. Okay, so mode I think and it is there in the pandas, so we can use it. Okay, so as you remember guys, in the previous video we saw, right, statistics types. So there are two types, descriptive as well as inferential statistics, right? So first we are going to talk about descriptive statistics. So you have been given a population data and what you are going to, what data is going to describe about it. Okay, so under that we have central tendency, that is mean, median, and mode. So let's talk about what is mean. Okay, so I'm going to share in the whiteboard. So let me use black color. Okay. So first we will see what is mean. So mean is nothing but talks about average of the data. So data could be anything. It could be related to salary. It could be related to age. It could be any numerical data, right? But it will be talking about average. Okay. So how to calculate the average? So let's say you have given a data x equal to, let's say, 1, 2, 3, 4, 5, and 6. Some data. Okay, so as per mean and its formula, what it tells, basically take the summation of all the values of x, let's say I. So I is nothing but from 1 to n. Okay, because you could be representing data from, right, 1 2 3 4, right? It's numbering start from 1 and up to n. So whatever this n data you have, right, take the summation and divide by n. This is your mean formula. Okay, so let's go ahead and calculate the mean. So we'll add 1 plus 2 plus 3 plus 4 plus 5 plus 6, divide by total number 6. So it is coming, this is 4, 5, 6. Okay. So 1 plus 2, 3 plus 3, 6, 4, 15, 21. Right. So it will be coming around 3.5. Okay. So now you got the mean of the given data. And if you talk about this, right, where is the center? What is central tendency of this given data? Okay, so now we got 3.5. If you put in the list, it is coming somewhere in the middle, right? That's what it's talking. So central data is coming around 3.5. Okay, that is what is your central tendency or mean of the given data. Okay, so let's see in the Python and how we can calculate it. So I'll be generating some random data also, or maybe we can just hard code also. A equal to, let's say we have a list. Okay, and how we can get the mean? So if you're using a statistics library, we have directly available function like mean, median, mode. So I can just give mean of E. Okay, this is what we saw, right? In this picture, 3.5 by adding all the values and divide by total number of values. Okay, there are another ways. So I'll just generate one np dot array, let's say a range, I'll mention 1 to, let's say, 7. Okay, if you print a here, it is 1 2 3 4 5 6. Now how to take? So a dot, you can directly take mean also, because numpy, we have already seen this under numpy tutorial, right? Mean, median, those functions are already existing, so this is also going to give the same values. Okay, now let's go ahead and do some plotting, how this data looks like. So right now I'm going to talk about kernel density estimation plot. However, I'm going to explain this in the next video, but let's plot the value, plot the data and see how it looks like. Okay, so we have sns dot kd plot and we'll just plot a. Okay. So this is your KDE plot and it will just give the value and their density, it will be plotted. Okay, under this data, what you are getting it. Basically, the peak which is shown here, right? That is telling the mean of the data. Okay, so mean we have already seen 3.58, which is coming somewhere here, right? So right now it is not visible. What we can do, I'll just plot it with the help of plt dot, let's say, v line, and v line is nothing but plotting a vertical line. Okay, so I can runtime calculate the mean. So my x will be, let's say, np dot a dot mean, and y will be from 0 to, let's say, what is the max value? This is y min, 0 to, let's say, I'm plotting 0.16 because that is the data we have, right? So y max equal to 0.16. Let me give color also so that we can highlight the vertical line. Okay, so that's where your mean is, like that's what you see, right? This peak is talking about the mean of the data or central tendency of the given data set. Okay, so that's how you calculate the mean, but there is a fundamental problem with the mean. So I'll tell you what is it. Let's talk one example. Let's say you are gathering the salary of a person, right? So salary is, let's say, between 1,000 to, let's say, 10,000. Okay, so you have got the all salary data from all the person, but let's say there is one person who is having salary, let's say, 50,000. Okay, so out of 1 to 10,000, there is only one guy who is drawing 50,000 salary. So that kind of data, or which is like almost unique kind of data, which is not common across like 1 to 10,000, will be called as outlier. Okay, so this outlier is going to affect your mean. So let's see how it is going to affect. We'll see the example here. Okay, so here we have a, that is one. So let's say this is some age, right? I talked the example for the salary related, but here let's say we have age. Okay, so okay, so age of a person, but let's say we are going to append, I'll append, let's say, 50. Okay, so what will happen? A dot mean, before adding we got 3.5, but after this a dot append, what is happening? np dot append 50 on a, anything is fine. Okay, dot mean. Okay. So new a will be, let me just run again. So we have a dot mean, just try to append. So it is going to take array that is nothing but a and their value, right? So value will be nothing but, let's say, 50. Now after that, if you print a, why it is not adding? Okay, it is going to make a copy, right? So let's create a copy, and I'm just going to add this. Okay, so 1 2 3 4 5 6 and 50 is added. Now if you take the mean of b, right, what will happen? See here, there's a huge change in the mean. Okay, now this is going to affect all your whatever conclusion you are going to make, right? So let's say average salary was 3.5. Down the moment the one person has come and their salary is very high, right, other than those common people between 1 to 6, right? So what you can do, you can just tell, okay, their average salary is 10, which is not correct, right? Because this is an outlier which is affecting your data calculation. Okay, so what you can do now, if you are going to plot this data again, sns.kd plot, you see you notice that how it is going to affect. See, earlier it was like normally distributed because 1 to 6. Okay, and now here you have data which is skewed now. Correct. So what is skew and all, which I'll talk later. But you can see here, the moment one outlier has come in your data, how it is going to affect your mean, how it is going to affect your kernel density estimation also. Okay, so that this is the problem with the mean. So how to overcome with this problem? We have something called median. So what it does basically, it will take the same data set, it will first sort the data. Okay, after sorting, it is going to do the mean calculation. Okay, so if number of elements in the given data is odd, then it will take the center value. If it is even, then center value, whatever two center values are there, it will take the mean of that. Okay, so how we can get that? B dot mean, not mean, actually median. So here I'll take direct formula from statistics and calculate the B. Okay, you see here. So it is very close to the central value of the normal distributed value, which is 1 to 6, right? So earlier it was 3.5. Now we have added one outlier, and after adding outlier also, their mean is not going to impact much. Okay, using median, it is just 0.5 unit has expanded. That's all. So you see earlier it was 3.5. Now it is 4. Okay, so that's how, so whenever you have outlier, always go with the median. So that's what we have seen, right, in our exploratory data analysis also. Instead of going with mean, we directly go with the median because it is not going to impact your mean part. So how it is basically solving the issue. So let me just show you. So let's say you have median. So given data is, let's say 1, 6, 4, 5, 3, then 2, right? So what you will do first, you take the data and sort. While sorting, what it will become 1, 2, 3, 4, 5, and 6. Okay, the moment you got all the value, it will take the middle value. Okay, so since it is having even number of element, right? So it will take the first center value and second center value and take the median of this. So 3 plus 4 divided by 2. So total 7 by 2, nothing but 3.5. That's how median is getting calculated. Okay, if you would have added 50, then what would have happened? So let me just clear it. Go to the next one. Okay, so let's say you have another value here. So data, nothing but your 1, 6, 3, 50, 2, 4, right? 1, 2, 3, and 5 is also there. Okay. So first it is going to sort 1, 2, 3, 4, 5, 6, and then 50. So now how many elements we have? Total we have 7 elements. Okay, so out of 7 elements, the middle value will come, like it will divide by 2. So 4 will be your median. And that is what we got, right? After adding 50. That's how it calculates. Okay, guys, so that's about median. So we have already seen, right, in the mean after adding outlier, how it impacts the data, how it impacts the mean part. Okay, so this is about mean. Now let's go ahead with mode. So mode is what? Most frequently coming value, whichever is there in the data, that will be taken as a central tendency of the data. Okay, so for that we have, let's say a equal to, we have one, it could be any numerical value or it could be categorical value also, right? So when I talk about numerical, it is, let's say, discrete value. So 1 2 3, then 2, then 4, then 5, then 4, then 4, 6, 7. Okay, so mode, what it is going to return is basically the most frequently occurred value. Okay, so which is coming, the number 4 is coming more frequently, right? How you can get to know? You can go ahead and calculate using dictionary comprehension. You take each element and put their count also, right? So what I'll do for, let's say, num in a, count a, and dot, sorry, a dot count n. So this will tell you which number is coming more frequently. For num in hashable type list, what happened? For n in a, okay, a dot count looks correct. It is something like this. For num in a, num. This is correct. And let's talk about dictionary. This is also fine. A dot count num. Okay, now here it is. So we have all the number and their respective count, right? So what it is telling, I think 4 is the one which is coming more number of times, or highly occurred value, right? So that's why mode is returning 4. Okay, so overall central tendency of this data set where we are talking about the mode, right? So highly occurred value will be your answer. Okay, so where exactly we use, mostly whenever you have data set where a lot of categorical values are there, so and some missing values are there, right? So instead of dropping that observation, you mostly go with the mode of that particular category. Okay, that's where we use. So you may have question where to use mean, median and mode, right? When you don't have any outlier, either you go with mean or median, both are same. When you have outlier, go with the median. And when you have categorical value and a lot of missing values are there, to replace the missing value with some known value, go with the mode. Okay. So yeah, that's about mean, median, mode. So let me take one small example here, a small example of data set, and let's do some analysis. Okay, so here under SNS, if you guys remember, I already told, right, it has default data set. So we have data set called iris, right? So let's load it and create a data frame, df dot head. Okay, so it has 4 features and 1 target value. Okay, so basically it is plotting the sepal length or petal length and petal width and sepal width for a flower. Okay, so that flower category is setosa and versicolor and virginica. Okay, so we can see those details also. So df dot species, if you see, then unique. So we have setosa, versicolor and virginica. So those are the different flower type, and based on their different measurement of sepal length and sepal width, petal length and petal width, they have given the category. So if you see here, total df dot shape, how many observations are there? So total 150 observation and 5 columns. Okay, so now let's go ahead and do some plotting. So here I'll take SNS dot this plot. Maybe I'll take df dot petal length, and hue part I'll take as df dot species. Okay, so why it is not taking? Let me give data as df, and we have x equal to petal length, and hue is df. Since we have already given df as data, so we just have to give the name of the species. Could not interpret value petal length for parameter x. Okay, so let me just see. Data, then x. Yeah, this should be fine. Okay, so it is plotting the histogram, right? So let's do some more addition here. So we will make what is that parameter? Let me just take a look here. We have something called kind is by default histogram, right? So we'll make it kernel density. Kind equal to, let's say, KD, and we have something called rug, just to plot data below the graph. We'll make it true. Okay, so this density estimation for the petal length, what exactly it is going to tell? Okay, so let me just talk about this a little bit. So I'll pick the pen. Okay, so here, as we mentioned, right, in the whenever you do KD plot, right? So basically KD plot, how it looks, this one, right? So this is nothing but, this peak is nothing but your median value. Okay, so here also this peak, this is the peak for species Setosa, and this peak is for versicolor, and this peak is for virginica, right? So what it is representing, your median value, or this one is somewhere in between, let's say 1.4, right? And for this, your median value is, let's say 4.2, right? And here we have median value somewhere in maybe 5.5. Okay, so I can just prove it by taking the individual value also and printing it, right? So what I'll do now, let me just, okay, if I cancel, then this marking will be gone. So let me explain first, then I'll prove it. Okay, so what exactly it is basically, right? So whenever you have this plot, right, whatever is plotted, so between this plot, whatever gap you see, right, this is nothing but your spread, how your data is spread from the mean or from the median, right? So this particular spread, like let's say your mean and max value is coming somewhere between 1.4, so let's say 0.5, that is your spread. Okay, so this will be positive and negative. Here in the negative side also you will see 0.5. Okay, that is your spread. Similarly here, if you see 4.2, so 4.2, it is almost close to 1.2, right? So this is your spread for particular, right? So 1.2 is spread for this particular region, and for here it is like 4 to 5.5, it is nothing but 1.5 spread for virginica. Okay, that's how spread is there. You can see from your plot, and this peak is nothing but talking about the median. Okay, so that's how, whenever you plot these kind of graphs, right, it is going to help you to get the median part easily, and how your data is spread. So more the spread means your variations are more, lesser the spread means less variation. That's what it tells, right? So what I'm telling here is, so let me take the color here. So let's say you have some data here. Okay, so your mean part is somewhere here, right? So if you have more spread, right, this, if it is more wide means you have a lot of variation in the data. Okay, let's say there is one plot here, something like this. Okay, so your mean part is, or median part is somewhere here, right, x. But here you see most of the values are lying between x. Okay, so maybe x plus minus 1 plus minus 2. Okay, that's all. And all that's why you see the peak here and your median here, and spread part is very less. So lesser the spread means variation is very less. So whenever you do any kind of KD plot, right, by looking at the spread or looking at the width of the graph, right, you will easily get to know how much variation is there in the data. Okay, so that is how you get the description from this particular graph. Okay, that's what this data or this particular graph describes the data. Okay guys, so that's about mean, median, mode. We'll see a lot of other details in central tendency. We'll see interquartile range and percentile and couple of other details in the next video. Okay, I hope this basic is good enough and you will start interpreting the data by doing the Kde plot. Okay, so that's all. If you did not understand anything, please put the comment in the comment box and I'll definitely help you guys to understand better in the next video. Okay, thank you guys so much. Bye bye.